D and E are the midpoints of sides AB and AC of triangle ABC, and O is any point on side BC. O is joined to A. Okay, we need a diagram to understand this. So I'll be showing you guys a 3-marker version. And from that you will learn how to answer or think for a MCQ also. Right? If you don't have the basic thinking, then there's no point in answering any question. Now we have this to be triangle ABC, and we have DE is the midpoint, so this is the midpoint, and AC is the, for AC, E is the midpoint, and so we have this to be parallel to this. Why is that? Midpoint theorem. Then O is any point on BC, so I'll take some random point, I guess that, and then we'll join AO. Then we have P is a point, P and Q are the midpoints of OB and OC. So midpoint over here is somewhere over here, and this is the midpoint over here, and we need to join this. So what do we end up with? This is clearly a parallelogram. Okay, we can conclude the answer, it's a parallelogram. But how do you represent it as a 2-marker version or 3-marker version is something that I'll show now. How to write this answer. So let me start off with the working. First we'll talk about in triangle ABC. Right? We have D and E being the midpoints of AB and AC. So this implies DE is parallel to BC. This is because of midpoint theorem. Okay. Then what else can we tell? Then we have in triangle ABO. Okay, if you guys are wondering how do you prove that D, this is, by the way, I think this is Q and this is P. Q and P. Okay, how will you prove that? We have DP being parallel to EQ. For that we have to consider the following scenario. Something like this. So what is that we're looking at? Triangle ABO. Here what do we have? We have D and P are the midpoints, as D and P are midpoints of AB and BO. So what do we have? We have DP being parallel to AO. Okay, so then we have in triangle AOC. So here too we have a similar thing, as E and Q are midpoints of AC and OC. So this implies what? From this we can conclude that AO is parallel to EQ. So from 1 and 2 what can we conclude? From 1 and 2 yes, we can conclude that DP is parallel to EQ. Now, so we proved that opposite sides are parallel. So it can be a square, rectangle, parallelogram or rhombus. How will you prove that it's a parallelogram? The opposite sides are equal and parallel. Okay, opposite angles are equal. The diagonals are not equal and they bisect each other. These are all the properties. So we are trying to prove that basically it's not a square, rectangle or a rhombus. Okay. So for rectangle, if I prove that the angles are not equal to 90 degree, so the rectangle and the square goes off. then the fight is between parallelogram and rhombus. Okay guys, so let me prove that the angles are not equal to 90 degree. So let me call this as angle, or it's okay, we can directly call this. So I'm considering angle, this angle guys, BOA, right? Okay, so the next bit of writing is something like this. We'll go with as O is a random point. This implies angle BOA can be an acute angle. Agree? So with this, what can we tell? Thus, angle PDE is also an acute angle. Can be an acute angle. Not is also. Can be an acute angle. So how can we conclude this? This is because of, see, which color? Yeah. This is because we have DP and AO are parallel to each other, and also AE is parallel to AQ. So we have this structure to be a parallelogram. Is it not? Right? So we can call this as T or something. So because DT OP is a parallelogram and opposite angles of parallelogram are equal. Agree? So we just proved that one of the angles is not equal to 90 degree. So we eliminated it being a square if not a rectangle. And at last we can talk about the adjacent sides not being equal to each other. Okay, so how will we prove that? As AB, as BC is clearly not equal to AO, right? It will not be, there's no condition, there's no scenario. So we have BC not equal to AO, BC not being equal to AO. So what can we tell? We can tell that BC not equal to AO, we can tell that DE is not equal to DE is not equal to DP. DE is not equal to DP. DE is not equal to DP. Okay. Right? The reason being DE is half of BC and DP is half of AO as per midpoint theorem. Again, this is only for, yeah, if it comes for 3 marker, we need to write all of this. So I hope you guys are understanding about the properties, how we are trying to eliminate. See, everything over here is to make you guys get familiar with the idea of the structures and their sides and angles and diagonals and all of that. So please understand that this answering is only for your a better understanding and better revision of the topic. So you need to be aware of what we are doing and what we are trying to conclude over here. If not, see, answering this will take a second, that's all. But understanding and writing it, having a deep understanding is very important. Therefore, DEQP is a parallelogram. Why? See, the reasoning, here we are putting the reasoning across, and thus we will be learning about the property of a parallelogram. This is because of opposite sides are parallel. Then we have an angle is not equal to 90 degree, and also we have adjacent sides are not equal. So we are explaining all the reasoning. Why is it a parallelogram and not a kite also? Not equal. Okay, yes. So this answering is a kind of a combination of answering MCQ question and also answering a 3-mark question wherein they're telling prove that the structure is a parallelogram but not a rhombus. Something like that. So yeah, you have to get matured about what to write, how much to write. Okay, so it's kind of tough for me to just guide you through all of the factors. It'll just confuse you guys. So one thing at a time, is it not? So get matured, try to understand what we are trying to prove over here. I'm trying to show that the structure is a parallelogram for sure, not a rhombus, not a rectangle or a square. So we could have ended up answering yes, it's a parallelogram, but yes, we need a reasoning. And with that, we're learning properties of all the structures. So that's the main intention. And now you guys can pause and have a look at the answer.